Hello everyone, welcome to the channel. So in this video, I'm gonna show you analyzing MODIS land surface temperature data with the time series method in Google Earth Engine for any study region. So now let us take a look at this data. So MODIS land surface temperature. So it is data availability is from 2000 to 2023. So data provider is NASA LP. And to access this particular data, you have to use this particular set of code. And let us view the description of this data. So this particular data provides an average of 8-day land surface temperature in 1200 by 1200 kilometer grid. And then this product, along with the both day and night time surface temperature bands and the quality indicators are QC layers, and also the MODIS band 31 and 32 and 8 observation layers. Now let us take a look at this band. So now we can able to visualize the band resolution is around 1000 meters. So these are the different bands that is available in MODIS land surface temperature data. So LST day 1 kilometer. So now for this video, we're going to use this specific band that is LST day 1 kilometer. So there is a variety of different bands available. You can also take a look at this band. So now let us get back to our Earth Engine. So here, to visualize our MODIS land surface temperature data, the emissivity 8-day global 1 kilometer data, so we defined a variable called dataset equals to image collection MODIS 061 mode 11A2. So in that, we're going to filter with a specific time period. So we're going to filter a specific time period. For that, we can define dot filter filter dot date. So we define the specific time range here, starting from 2023 January 1 to 2023 August 21. So next, to access the specific band, that is, we're going to use this specific band that is LST day 1 kilometer. So for that, we defined a variable called land surface temperature equals to the dataset dot select LST day 1 kilometer. So the dataset refers to this particular variable here. So in that, we're going to access our MODIS land surface temperature. So from that, we are selecting specifically this particular band called LST day 1 kilometer. So now next, to set a visualization parameter for our MODIS land surface temperature dataset, we defined a variable called land surface temperature vis. Vis here represents a visualization parameter. We set a minimum value of around 14,000 and to a maximum value of around 16,000. So the color palettes we are choosing here, these are different color palettes. So now to center the layer, we define map.center, set center, with specific latitude and longitude with a zoom level of 2. So now to add this layer into our Earth Engine, we define land surface temperature. So referring to this particular variable here. And now for the visualization parameter, we define land surface temperature vis. So referring to this particular variable. And output the layer name as land surface temperature. So this particular set of code, we can able to visualize our MODIS land surface temperature. So now next set of code is going to function to estimate the land surface temperature for any specific study region of your choice. So for that, we defined import. We're going to import our data, that is our MODIS land surface temperature data. So for that, we define a variable called collection equals to image collection MODIS 06 MODIS 11A2. And we are selecting a specific LST, that is our LST day 1 band from our MODIS land surface temperature data set. We're going to select the specific band LST day 1 kilometer. So we're going to filter with the specific time, that is from 2020 to 2023. So we're going to see the variation of the temperature, variation of this land surface temperature for any specific study region from 2020 to 2023. So we're going to filter bound with the specific study region, that is ROI, that is our region of interest. So we have defined a polygon here, that is a ROI. Now let me show you that. So now we can able to visualize. We have defined a specific study region. So we're going to measure the LST for this specific study region. So for that, we have created this particular ROI, that is our square polygon here. So now I will delete it and show you once more to how to create it. So we have to navigate to this option called draw a rectangle. So once you did that, we're going to draw a rectangle over the specific area here. So I have drawn a rectangle over the specific area. So now let me rename. So yeah, it is renamed as a variable ROI here. So make sure that you define a variable as ROI. So now I've shown you how to create an ROI, that is our region of interest, to measure the land surface temperature for that specific study region. So next we have to perform some pre-processing on the LST data and convert. We're going to convert our Kelvin to a Celsius unit. So for that we defined a variable called LST day equals to collection.map function img. So return img dot multiply 0.02 and dot subtract 273.15 dot copy properties. And so we have the specific set of code we are using is that we're converting our Celsius to Kelvin to Celsius. So for that we are using the specific set of codes here. And now to display our annual land surface temperature variation, we defined a variable called chart equals to ui.chart.image and doi series by year. So LST day here refers to our this particular variable here. And now we can able to visualize here LST day 1 kilometer. This is our chosen band. So now we defined ROI. So this is our ROI here. This is a specific study region we have chosen here. So here the reducer dot mean is it is used to calculate the mean value of the each day of the year, and this is a spatial resolution of this particular data, that is a 1 kilometer. So this is represented as 1,000. So now to view this result, so we define print chart. So now let us run this code. So we're gonna move on to this option called run script and click run script. So now let us take a look at this data here we're gonna generate. So we can able to visualize the colors here. The high LST, the land surface temperatures are indicated in this specific color, that is in dark red, and the low surface temperatures are indicated in blue color. So this is the highest range of LST and this is the lowest range of LST. So here we have selected this. So now we have displayed LST for the entire globe. So now to estimate the LST for the specific study region, so we have defined this particular. We have created this ROI for this particular study region. So using this ROI, we can extract the LST value for that specific region. So now we can able to visualize here the graph in the console section here. So now we're gonna expand this one. So now in this graph you can able to visualize here. So in this axis represents a day in the year. So that is you can represent from 0 to 365 days. And similarly the temperatures are here represented that is in Celsius, starting from 22 degrees Celsius to 42 degrees Celsius. It is represented here. So this particular axis represents our Celsius, the temperature in Celsius, and this particular axis represents the day of the year, starting from 0 to 365 days. And this specific lines here represents the year. So in 2020 represented in blue color, and the 2023 is represented in green color, and 22 in orange, and 21 in red. So we can able to visualize here. So the blue line here indicates the temperature versus the days of the year, So from here you can able to observe the highest level of temperatures being observed in this specific month. So here you can able to observe in the day 150. So there is a highest level of temperatures observed here. So it is around 41.97 degrees Celsius. So for this specific study area, the temperature is very high during the month of April and May. And this specific day of the year indicates the month of May has a very high temperature. And the lowest level of temperatures observed in this period, that is around 325 year. So that is a 325 day of the year. So that is in December. So the lowest level of temperature is observed in this year. And similarly, you can observe each color indicates the different year. So you can observe the different temperature during that particular year for the specific study region. And now let me get back to our Earth engine. So in this video, I have shown you how to estimate the MODIS land surface temperature with time series method in Earth Engine for any specific study region of your choice. So thanks for watching, and please subscribe to our channel and give us a like.